Hello, welcome back. It's been a while. New year, and I finished up some of those other projects at Big Poacher Model. Finally got that over to my friend's house. Spent the past couple of weeks really cleaning up the garage, getting my workbench all cleaned. So I'm excited to start another project. This is not the project I'm going to be starting. This is just going to be a quick, like a weekend build type of thing. I'm going to be starting another model, but for now, I've been wanting to build a linear actuator for a long time. Now, this is not one I've built, obviously. I'm just using this as an example. And at the moment, I don't really have a use for a linear actuator, so I'm just going to kind of make something that I guess what you'd call general purpose. But if you're designing your own, you need to take your design into you got to think about what you're using it for. Are you using it to move a really big heavy load? Do you need a lead screw this big, or do you just need to move a light load back and forth for special flex, like Halloween props or something like that? You could get away with a much skinnier load. Now, this particular actuator is not self-driven. Notice there's a shaft here. This shaft would connect to a torque tube, which would be connected to an external hydraulic motor, or a separate hydraulic motor that would then drive this. The one I want to build will have an electric motor built into it. Also, this one, when you turn the shaft, you're actually turning the nut. So with this one, you're turning the nut but driving, which is going to move the screw. What I'm going to build, I'm going to turn the screw and drive the nut, just because for me that would be easier. But those are just some things you need to think about. How long is your throw? How big is your lead screw? Are you going to have it driven internally or externally? Are you going to turn the nut, or are you going to turn the screw? Now, I decided to build this using parts that I already have. So just going through my scrounge, I found this threaded rod. And this one would work fine, but for what I want to build, I thought it seemed a little bit big, and I found this threaded rod, but this is a little bit flimsy for what I want. So I was kind of deciding between these two. And the nut that I want to use, I always knew I wanted to use one of these long, it's like a threaded rod coupling nut. It's like a nut, but it's longer. But I don't have one of these for either of these. And I had two of these. So I went to Lowe's and I bought the threaded rod that would fit it. So this is my Goldilocks rod. That's too small, that's too big. This one's just right. So we'll get rid of those. So now I know I'm going to turn the screw so the threaded rod will remain stationary, and as it turns, the nut will move back and forth. So what I want to do is weld that nut to the end of this. That will go, and this is just a piece of square tubing. And so I'll weld that to the end of that. This will go inside of there. Then I'll have another square rod on top of that. And that's kind of the basis of what I'm doing here. I still need to pick the length, overall length, and I still need to pick a way to drive it. Now, scrounging parts, I ended up with that. And this would work perfectly fine. All I would have to do is, clamp this. There's still the price tag on that thing. All I have to do is, clamp that in there. If I turn that the right way, clamp that in there, and done, connected. I don't know if I like that or not. I'm going to see if I can maybe get rid of this and figure out how to connect that right to the output of here. I also have this one. It's got a square drive on the end, so I could figure out a way to connect that to the square drive. So I'm still trying to decide between these two. By the way, as I'm building this, I'm just kind of making it up as I go along. Now, a year ago or so, I made a rotary actuator. Well, I took a windshield wiper motor and I turned it into a servo. And somebody accused me of well, they left a comment and kind of claimed that or they thought that I claimed that I invented that, and that was not, I did not mean to come across like that. Obviously, I'm not the first person ever to turn a windshield wiper motor into a servo. I'm also not the first person ever to make a linear actuator. Hopefully none of you think that I'm claiming that this is my invention or my idea. So don't think that, don't go there. Now, the way I'm doing it though is my thoughts, my idea. I honestly did not watch a single video on YouTube on how anybody else is doing it. Well, kind of, one exception, James Bruton. You guys got to watch James Bruton. This guy is incredible. He does mostly robotics, and he's working on a what's called the Open Dog. It's a four-legged walking robotic dog. He also has a lot of bipedal robots, and he uses a lot of linear actuators. Now, the way he does it, and of course I watched his videos because I've been watching James for years, but the way he does it is completely different from the way I'm doing it. So I'm not copying him. For his application, the way he's doing it is better. You know, this probably wouldn't work very well for his application. It may or may not, I don't know. But my point is, there's probably dozens of videos of people making linear actuators. I did not watch any of them because I wanted this to be my thought process, my idea. I'm not claiming it's the best way or the worst way. If you learn something from it, that's the point of this video, is to put some ideas out, give you some ideas on how you can make your own. Later on, we'll discuss the electrical part for moving it. I don't want to get into that just yet. I'll save that towards the end. And again, I'm not exactly sure just yet which one of these I'm going to use, how I'm going to connect it. I think the first thing I need to do is figure out the length and weld that nut on here. Well, it seems like there's something else I wanted to say here. I'll think of it later. So let me just kind of put that stuff away and let's get that welded on. And I think what I want to do, and and also we need bearings. That's what I was going to say. You don't want the force of the screw jack directed to the motor. The only force you want here is rotational force. You don't want the weight or the pull to be on the motor or the motor mounting. So we're going to put some bearings in here. And I'll probably do, that's the wrong bearing. I'll probably have a couple of bearings in here like this. And I got some bearing blocks, I can put those in. And so those will manage the force of pushing and pulling. Of course, I have jam nuts on either side of that. I don't normally like putting bearings right on threaded rod, but for this, with the jam nuts on either side, it should be okay. If I can figure out a better way, then I'll do that. But yeah, normally I don't really like doing that. Also, when you're thinking about travel, typically on a screw type linear actuator, the overall travel is going to be less than twice the overall length of the actuator total. In other words, if this is connected here, this much of the length, actually, if all the way retracted, the nut is here, right? So this would be all the way retracted. However long the rest of the threaded rod is going to be your travel, right? Well, let's suppose that I cut it off right here. Well, this thing's only going to be able to move that much. So here to here, that's all it's going to be able to do. So you just got to think about, for your application, for your design, how much throw do you need? How long do you need it? And the way I'm connecting it this way, this adds a lot of extra length. If I put a gear on that end and I put a gear on this end, well, I could put that motor just like that and gear those together. And you can see how much more compact that makes the whole unit. I think I have some gears that would probably work. I don't know if I'm going to do it like that or not. I might. That's still kind of to be decided. But I'll probably just do it like that, or this motor, whichever one I decide to use. So still undecided there. I think if I put, I think I'm just going to pick a length and go with it. And we'll get my Sharpie out here. And I think I'm just going to go with something like that. I don't know, I got to think about it. Because like I said, since I don't really have a direct application, see, the plan is hopefully one of these days, if I ever need a linear actuator, I'll just be able to use this one. But I'll pick a length, I'll cut that. Obviously this has to be cut to match a little bit longer, and then I'll get that welded on. So let me get that done, I'll get back to you in a minute. Okay, so here's what I've got. The square rod, I just cut in half. You know, I said I needed to pick a length. I just picked a length out of convenience. So I just cut that square rod in half. And I welded the long nut on that side. Now I'm just using a cheap, it's like one of those $120 wire feed welders from Lowe's. It's perfectly fine for stuff like this. It's not the best welds. Plus I'm a little out of practice for welding, but it'll definitely hold. And I ground it down smooth because this has to ride inside of another tube. I'm going to put an outer tube on this to keep this from rotating. If you go back to our previous example here, on this one, this output shaft is free to rotate. But in use it doesn't, because the thing it's connected to cannot rotate, so that keeps it from rotating. On the one I'm building, I want it to not be able to rotate when it's not installed. So I'm going to have this inside of another square tube. That'll keep it from rotating when it's not attached to anything on either end. Now I don't really have to do that. It would work without doing that, but that would also kind of protect the threads. Like when this is all the way extended out, I don't want visible threads, so the other tube will kind of just keep all of that protected. I also welded a smaller nut on the other end. This will be used to thread end, not a bolt like this, but just a thread end like an eyelet or something, so I can attach this to something else. All right, but the bigger nut on that end is what's going to be driven from the screw. Now, as far as driving this, I still have a few ideas. Now, I went ahead and I took this one apart. And when I took it apart, I realized that I actually started, I forgot that I was using this for another project years ago. And if you'll notice, I actually already brazed in that shaft. That's not the original shaft. And I actually forget what I was using this thing for. Now, normally when you're attaching stuff, when you're attaching a motor to a screw lead, you don't want a direct physical connection, because if there's any misalignment, that's going to put everything in a bind. So ideally what you would use is something like this. This is called a Lovejoy. And so if there's any misalignment, this will account for that. It actually just comes apart like that. And so there's a plastic inner piece and then two metal parts here. This is a little bit small for this application. I mean, I could maybe make it work. You could also use those couplers that you use on your Z-axis on a 3D printer. Those aluminum things, but those, I don't know, might be a little too springy. I'm sure it would work fine, but what I'm going to try to do is actually mount that straight on there. Now again, that's not ideal, but if there's any wobble, what I will do is I will soft mount the motor, meaning I'll attach it with like rubber mounts so that if there is any misalignment, the motor can kind of move around a little bit if need be. So the plan is to thread this to accept that, and then thread all that together, put a couple of spot welds on it so it doesn't come loose. So that's the plan. Whether it works or not, I have no idea. But we'll take these bearings off. These are little roller thrust bearings. We'll just set those off to the side for now. And same thing here. We'll just kind of set those off to the side for now. And we'll see if I can put some threads on that for here. So let me, man, my hands are getting dirty. I'm not used to getting dirty when I work. So let me see how that turns out. I'll show you here in a second. And here's what it looks like welded together. Now I had to grind that down to match the diameter of that so I could reassemble it in here. And again, I just put a tack here and here, and then one here and back here, and that's just to keep it from unthreading. The actual threads will hold it together. Now it's not perfectly straight. I put it in the lathe and gave it a spin, and it wobbles a tiny bit. But this rod is flexible enough, and like I said, I'm going to try to mount the motor so it can have a little bit of a flex to kind of accommodate that little bit of a misalignment. Again, this was not the best way to do it. It is fairly straight, it is fairly good, but a coupling would have been much better. If it just doesn't work and it binds it all up, then I'll take it apart and try something different. You'll just have to decide that when you make yours. So putting this back together, we have, make sure you get the right ones. We've got little roller thrust bearings here. I should probably put some fresh grease on those. Let me get, all right, not the grease I wanted, but you know, this thing, I don't know if it will ever actually get used or not. So, not that big of a deal. Yeah, this is more, I don't know, maybe demonstrational purposes. Also, just my curiosity, just to see. That was the wrong end. I can't talk and think at the same time. My curiosity to see how well it works. I mean, if I had an actual purpose, then I would purpose build it, purpose design it. But since I don't, I'm just making stuff up to see if it works. And again, if it gives any of you some usable ideas, then it was well worth the effort. That goes on like so. And this, make sure I'm not forgetting anything. I'll put a little bit of grease on the gears. Come on, get together. There you go. And the screws. All right, so there is that. I'm really curious. Let me see if I can find a battery, and we'll test this thing out. All right, so I have no idea how charged this is. It's only like 6 volts. I plan on running this on at least 18 or 20. But let's see what it does on no more than 6 volts. There we go. I'm on. It's not too bad. It's got plenty of torque. And I think the speed is good enough. It's only a little bit of wobble. It'll be fine. A little bit of wobble never hurt anybody. Okay, what next? I think I need to work out the bearings and some way to hold this, and then an outer sleeve for this. So let me get to thinking about that, and I'll get back to you here in a second. Here's the main frame together. Just angle iron, cut and bent and welded. And you know, I don't get footage of that, mainly because right now with my setup, I don't really have a good way of moving the camera around and setting up at different shots at my different work areas, like where I cut and where I drill. But you know, you guys know what cutting and drilling and grinding looks like. I am working on a new setup for my camera though, eventually, so I can maybe get some different angles and different shots of stuff. But again, nothing special, just angle iron, cut, bent, welded, ground smooth. Eventually this will probably get a coat of paint just to keep it from rusting up. Had a hard time getting in here to make those look nicer. Again, they look like dog doo-doo, but they work, they'll hold. They're not going anywhere. But those brackets in here are used to support the bearing block. So let's go ahead and get this thing together. Oh, I also drilled and tapped a couple of holes here on each side. And I drilled a hole here. This is going to be used for a micro switch for an end of travel. I have a collection of scrounge micro switches, but none of them have a deep enough plunger to work here. And the idea for that is when the rod is here, it will release the micro switch and that will make the micro switch. So that would just be for an end of travel, but we'll talk about that more later. Let's put this thing together. Pretty simple. Pretty simple. You just take the threaded rod into here. You've got to flex it just a little bit, and then it drops down right in there. Those brackets hold the bearing block, and that's pretty much it. If I would have used a thicker threaded rod, I would have had to have done that different, because to put this in, I have to flex that rod up and down a little bit. This rod is slightly flexible. And I don't need to bolt that in. It'll stay right there. So all of the force from this actuator is going to be acted right here and not on the motor. And the motor will be free to move a little bit. Then we have this cover. This cover goes on here with these screws. And that is pretty much that done. All I got to do now is put the rod here in. And to do that, we'll put some power to this and we'll just feed it into the back side. I've been using just a 6-volt battery, but that is really slow. Let me go grab a 12-volt power source here. Okay, so I've got 12 volts hooked up. It's actually from a car charger. And we're going to take the rod and kind of just get it started in here and see if we can get this to start pulling that rod in. All right, and motor's not warm. Again, I don't remember what this motor was rated for. You know, I don't remember what drill I pulled that out of. It could have only been a 18 or 12 volt drill, but and that was 12 right there. But I want to do all the testing with 24 volts. Because as you can see, that was rather slow. But now you can get an idea. Let me get another shot of you at the end of this thing, maybe, if I can. Let me see, how do I want to do this? Get this out of the way. And we'll flip it around to that end, because that's exciting. And we'll just see. We'll go this way. And then, so, you know, it's not going to win any awards for speed. Not going to win any races, but I'm very curious to find out how much pulling and pushing force this has. So let me rig up the power. What I'm going to do is I'm just going to use the switch here out of a drill. This is not from the drill it came from, But I'll just rig this up to it, and I can just go one way or go the other way. So I'll get that rigged up, and I'll put 24 volts to it. Then we'll time it, and then we'll connect it to some scales and see how much force this thing has. So the eagle-eyed among you will notice that it looks different, because after I put it together, I realized I never put grease on it. So I took it back apart to grease it, and I also noticed that I never made a way to attach this to anything. So I just welded on a couple of nuts here, so I could just put some bolts in and secure it. And again, I just went ahead and put a coat of primer on it just to keep it from rusting. And again, I know the welds don't look good, so if you're going to comment, at least be original. Now, my welder, I think I said before, is a cheap $100 Lowe's unit. This thick of material, it really struggles with. I've got to get a bead on it, and I just have to hold it there until and I could see, the puddle just kind of sitting cold on top, and I have to hold it there until it gets hot enough. Then I can see it melt in. Then I can start. Well, the whole time it's just building up more and more weld. I have the wire feed turned way down. That helps a little bit. It's just a cheap welder. Plus, I'm out of practice. I only use it maybe once or twice a year. And I'm not making excuses. I'm just merely explaining why the welds look like crap in a way that makes it sound like it's not completely my fault. I also temporarily wired in the trigger from a drill. Again, this is temporary. I had an idea of, I don't remember if I told you this yet or not. I had an idea of putting two of these side by side this way with a lever. So you move the lever and it would move that, but this one doesn't work. So I only have one that works. So I can flip the direction, And again, I think I already mentioned, I don't want to talk about the electronics here. There's countless ways to hook up electronics, as far as into-travel limit switches, linear potentiometers, rotary encoders. You can control it with relays, mechanical switches. You can control it with a microprocessor. Again, that's countless. I could have a whole video just on that. I just wanted to focus on the mechanics of it. And so it's all back together. It's lubricated. I've got a way to test it. So let's just set this up and let's do a speed test. I'm just going to see how long it takes to move 12 inches. It has a full travel of 16, which, you could make that anything you want. You could make it with a 1-inch travel or a 10-foot travel if you had enough threaded rod. So I'm just going to time it over 12 inches. And I got a scale, a push scale, or a fish scale. It's a pole scale, actually. And I thought I had one that would go up to 200 pounds. And I guess I was imagining that because it only goes up to 80. So I'm sure it will have no problem pulling up to 80 pounds. But we'll test it and see what it does. So anyways, let me get this set up and we'll do some testing here. I need a bigger scale. Okay, so as you saw, it does 12 inches in about 15 seconds. That's, for those of you whose math is as good as mine, that's about 4 feet a minute. Now, I fully, or like, would it be like just a little over, an inch a second. No, I said that backwards. Just a little over a second an inch. Now, I fully intended on testing this on 24 volts. And I was going to do that because I have two 12-volt batteries, or like smaller than a motorcycle battery. But one of those batteries is completely shot, just completely dead. And it's just a bad battery. So I only tested it on 12 volts. So with 12 volts, it takes a little over a second per inch. With 24 volts, it would be faster than that. Theoretically, twice as fast, but I know in reality it wouldn't quite be just like that. So I'm going to say if you ran it on 20 volts, give or take a couple of volts, it would probably go a little faster than an inch a second. As far as the pulling test, yeah, it had no problem pulling that 80 pounds. I'm going to see if I have another scale at work. I don't know if my work has a fish scale or not. I thought of a way to try to rig this up to see if it would lift me. I'm assuming it could lift a couple of 100 pounds. But the fact that it did 80 without even slowing down at all, I'm sure this could do well over 100, probably even a couple 100 pounds. If I'm going to end the video here, but if I do another test on this with a higher force scale, and I see that it can lift 200 or 300 or 400 pounds, then I'll let you know in a later video. But again, for now, I'm going to call this done. It is usable as is. If I were to put this into a project, I would cover this up to keep crap out of here. So I'd make a cover for this. I'd make a cover for the back of this. I would do some more permanent wiring. But for testing and experimenting, yeah, that's a word, purposes, it served its purpose. And I'm happy with it. Now, things I would do different. Like I've said before, if I were to build another one, it would be purpose built. It would have a specific function. It would be a specific size, shape, and I would design it per that. I would do a much better job of designing an enclosure. Things I don't like about this one, I could have made it a lot shorter. Well, 2 inches shorter. I could have easily made that 2 inches shorter. I don't like that I welded the rod right to the output shaft of the motor. It works, but it's not the most elegant way to do it. I should have put a coupling, like a Lovejoy coupling, or I could have put this beside it with 2 gears. It would have been wider, obviously, but it would have been better. Now, I do like how this is skinny and streamlined because it could fit in a tighter space, so that is one reason to put it in line. But I think my biggest thing I don't like is the way I connected the screw shaft here. And I kind of rushed making the enclosure. This could have been better. Also, the type of screw, I would use a different screw, probably more of like a ball screw or something like that. But again, threaded rod like this is slow but strong. So again, it depends on your purpose. Anyways, I'm going to stop rambling because I feel like I'm repeating myself. Hopefully you got something out of this. Hopefully you learned something here. Hopefully you got some ideas. You know, if you want to copy this exactly, have at it. I don't care. But I wouldn't do this exactly again. But by doing this, I did learn a lot. I learned a lot about what I should do, what I shouldn't do. I got a lot of other ideas for building other actuators. And hopefully this gave you guys a few ideas as well. So I feel like this video is going to be way too long. I apologize. Thank you so much for sticking in there to the end. And I'm going to clean up my workbench, and I'm going to start one of my 1/8 scale model kits, probably the Jaguar or something like that. So anyways, as always, thanks for watching.